Okay, 5.2 inverse functions. No, this is gonna go kind of quickly because this should be a review. Does that make sense? You learn about inverse functions in Algebra 1 and you learn about inverse functions in Algebra 2. It is not anything new. Okay. Yeah. Continuing. So we're gonna go through it quickly. The assignment is already posted. The other thing is on Monday, here's what we need to go over inverse function. It's because we're gonna be talking about exponentials and logs, and they are inverses of each other. Okay, and so that's why we're reviewing this concept. All right. Let's go. The first thing we're gonna do is define some of the important vocabulary that you should already have knowledge of. Okay. So hopefully I left you enough room. I'm on a mission to do 1-page notes. And so hopefully it's one single page printed. All right. So first, it says inverse function. What is an inverse function?
Function that's inverse.
Yes.
Okay. All right. Anyone else?
A function that's inverse.
Okay.
You're right. Wait a minute.
I'm helping you.
Anyone else wants to try to take a stab at what an inverse function is?
Function inverse.
A what?
So it's like function. It's when the function is turned into a negative. The signs are flipped.
Okay. An inverse function is, we learned that is when your x and y, your domain and your range are switching, right? The domain and range of one function becomes the range and domain of the another function. Okay. So when we I'm not so if you have two functions f and g, we can say that if f composed of g of x equals g composed of f of x, and they equal x, then G is an inverse of f. So therefore, we would say G of x equals the inverse of f. Do you see why we study composition before inverses? Composition is what is used to define an inverse function. Okay, a one-to-one function. A function is one-to-one if for any a and b in the domain, we have that. It means that if we have any value, any a and b in the domain, that f of a equals f of b, therefore a has to equal b. And the reason being is because no repeating x values and no repeating y values. Okay, so therefore, if I'm saying a and b have the same y value, a and b must be the same number. Does that make sense? I like to say a one-to-one function is a monogamous function. Okay, for every x, there's only one y, and for every y, there's only one x. Okay, horizontal line test. The horizontal line test is our visual way to test for one-to-one. So it's just it's very much so like the vertical line test. Instead you go horizontally. Okay, and you only want to hit how many points at a time? One. Only touch one point at a time. Okay. All right. So these are our main three vocabulary words for this unit, this section. Inverse function, one-to-one, horizontal line test. Are all these words familiar? Okay. All right. Am I good to go? Okay, inverse function. So it says for a function f that is defined by a set of ordered pairs, to form the inverse function of f, you're going to do what? Someone said it earlier.
Switch the line.
There we go. We're going to switch or interchange the x value and y value. Whatever our input and output are, right? Of the ordered pair. Okay, and you're doing this for every value. I'm about to write down. You don't have to write this down because you probably don't have room unless you want to write small underneath. But so for example, if I have this set of points on a graph, let's say 4, 1, 3, 2, and 1, 0. And I want to find the inverse. This should be an S, not an F. What am I doing to the set to find the inverse? Switching the y and the x's. So this is going to become, and this becomes, and this becomes. Okay, do you remember doing that in Algebra 1?
Yes.
Yes, okay. Again, did you have to write this down? No, it's just a refresher of what this is telling you. All right, next it says for a function f and its inverse, what is the relationship between the domain and range, basically? Okay, the relationship is the domain of f is the range of the inverse. It's the range of the inverse, okay? And the range of f is equal to the domain of the inverse. Okay, so thinking about the points we just did, if I was to make a table, notice how the x's and y's are literally being switched around, right? How do we verify? So to verify that two functions, f and g, are inverses of each other, we're going to have to use composition. Use composition. Okay, so how do we verify? Use composition. So you have to do it twice. So we're going to look for f of x, not f of x, f of g of x. Yep. You saw nothing. And then we're going to see if it equals g of f of x. And they both need to equal x. If true, then f of x equals the inverse of g of x, and g of x equals the inverse of f of x. Okay, so we use composition. Hopefully I left you enough room. So in your example space, kind of split the space in half because we're going to do one composition on one side and the other on the other. So you should have enough room where you can kind of split your little horizontal space in half. Well,
The function has to equal x.
so the composition of the two functions has to equal x. All right, ready to try it? So we're going to test it out. So we're given f of x equals 2x minus 3 and g of x equals x plus 3 divided by 2. And it wants us to show algebraically that these two are inverses, right? So first thing we're going to do is find f composed of g of x. which means that I am substituting in for x plus 3 divided by 2. So where there's an x, it's going to become x plus 3 divided by 2. That gives me 2 times x plus 3 divided by 2 minus 3. 2 divided by 2 is what? 1. So they become Casper the Friendly Ghost, and we're left with x plus 3 minus 3. What happens next? The 3's cancel out, and I'm left with x. So I now know that the f composed of g of x equals x, right? Now I'm going to do g composed of f of x, which means now I'm taking 2x minus 3. I said I tried.
Thank you.
I tried. I'm sorry. And now everywhere that there is an x and g of x, it's going to become 2x minus 3. So that gives us 2x minus 3 plus 3 divided by 2. What happens to the 3's? They cancel, and we're left with 2x divided by 2. What happens to the 2's? They cancel, they equal 1. And we're left with x. Do they equal each other? And is that value x? Yes. So guess what these mean? That means inverses. And that's how you verify inverses. Doable? Okay. All right. Next, we're going to talk about the graph of an inverse function. So the graph of an inverse function, we've already discussed when you're graphing, your ordered pairs are switching. So it becomes B, comma, A. And the graph of the inverse and the graph of the original function, they should be reflected over the y equals x line. That invisible dashed line through the diagonal part of your graph. Okay. The existence of an inverse function. Before you do anything, you can determine whether it's going to be an inverse function or an inverse relation. Okay. If you're looking for an inverse function, if a function is 1-to-1, that means that no elements or value, should use the word value, no elements of the domain or range repeat. Okay.
Jones, what song is this? Okay, that's it.
Thank you. If a function is 1-to-1, that means that no elements of the domain or range repeat. Okay. A function f has an inverse if and only if f is 1-to-1. Okay. I want to clarify, a function f has an inverse, that's a function. Okay. If it's a function. And again, to visually tell whether a function is 1-to-1 from its graph, you're going to check to see if it passes the vertical line test and the horizontal line test. I don't know, roll with it. You can improvise. You're smart. Okay. Now it could be an inverse relation, but it may not be an inverse function if it's not 1-to-1. All right, let's look at example 2. Looking at example 2.
And the horizontal.
And the horizontal line test. Yep.
You know, items for I would get one.
Good job. HLT and VLT.
What?
She sounds like she's been a already.
Yeah. All right, so example 2, does the graph of the function at the right have an inverse function? Explain yes or no. So we check to see, does it pass the vertical line test? And the answer is yes. Does it pass the horizontal line test? No, because if I had a horizontal line, how many points do I hit at a time? 3 at most, right? So therefore it fails the vertical line test. So would the inverse be a function? No. And why not? Because it fails the horizontal line test.
No.
Okay, it fails the horizontal line test. All right, the last part of our notes is to be able to find the inverse of a function. Okay, there are 5 steps that we're going to go through. Okay, to find the inverse of the function. Step 1 is we're going to use the horizontal line test to determine if it's a function. To determine, that's how you spell determine. If 1 to 1. Okay, if it comes back yes, you are good to go. If it comes back no, we're gonna go, but we're gonna have to see if there's a restriction that has to be applied. Saying, you're not quite good enough to be a function, but if you do this, you can be. Okay. All right. Now, the second thing we're gonna do, we're going to do what? Anyone wants to take a stab at what step 2 would be then? Did someone say switch your X and Y? Oh my gosh. Switch your X and Y. Okay. After you switch your X and Y, then you're going to use inverse operations. Operations to solve for Y.
Is that why it's called inverse operation?
Kind of. Inverse just means that you're doing the opposite of it.
That is
I mean, but yeah, in this sense you can. Okay, step 4 is once Y is alone, change to the inverse. So once Y is by itself, we make it the inverse. And apply needed restrictions. Okay. Last and final step is to check yourself. Okay. If you think you're wrong, guess what you can do? You can take your answer and plug it back into the original. And if it equals X, what does that tell you? You did it right.
Or we can just ask you too, Ms. Jones.
Nope.
Cause you're the bestest teacher.
Uh-huh. Okay. All right. Are we ready to go through the steps? So we're going to use HLT to determine if it's 1 to 1. If it's a no, we know that we're going to need to find a restriction if possible, right? Step 2 is we're going to switch your X and Y. Step 3, use our inverse operations to solve for Y. And step 4, once Y is alone, we change it to the inverse of X, F, and apply needed restrictions. Okay. And again, if I'm not confident by the end, what do I need to do? Check yourself. Okay. All right, here we go. Here we go. If we have f of x equals 4x minus 5, what type of function is this? Linear. Okay, so keeping that in mind, does a linear function pass HLT?
Yeah.
Yes. So I'm not going to have any restrictions. Does that make sense? It's going to pass. Step 2 is to do what? Switch x and y. Remember, f of x is the same thing as y. So we have x equals 4y minus 5. Step 3 is to use inverse operations to get y by itself. What is my first inverse operation I need to do? Add the 5. So we left with x plus 5. Exactly. We go through sad mep. We're going to sad mep it out. All right. What's my next inverse operation? Divide by 4. Is my y now by itself? Yes. So therefore, my inverse function equals x plus 5 over 4. Yes. And then if I wasn't sure of my answer, what should I do? There you go. Double check. Okay. I feel like I have a room of haters, but okay. Okay, was that terrible? Do y'all kind of, this literally came from Algebra 1.
COVID had my album one.
I know.
Year was Joe.
Yeah. All those things. But we also did this in Algebra 2 to compensate for your COVID.
I call COVID that year too.
Bye. All right. Yeah. All right, example 2. Example 2. It's a quadratic. Okay, and what shape is a quadratic? A parabola. A parabola. All right, does a parabola pass the horizontal line test? No. So that tells me that I'm going to have what in the end? I'm going to have to make sure I put a restriction. Otherwise, the inverse is not a function. Got it? I'm going to have a restriction because the inverse is not a function. All right, here we go. Step 2. Step 2 tells me to do what? Switch my x and my y. So we have x equals y squared plus 3. Step 3 is to use your inverse operations. What is my first inverse operation? Subtract the 3, and I get x minus 3 equals y squared. What is going to be my next inverse operation? Take the square root. And what I do to one side, I do to the other. And now my y is free, so it becomes the inverse of x equals the square root of x minus 3. Okay. So now I need to state my restriction. What can you not have underneath the square root?
A negative.
A negative. So what would have to be true in order for this to work? What's my restriction?
X cannot, X has to be greater than.
X has
to be greater than equal.
There we go. My restriction is x has to be greater than or equal to 3. Otherwise, would my inverse be a function? No. Okay. The main reason is because remember, there's always this in front when you take the square root of something. What is that? That plus or minus. So if I don't put that restriction, it's going to end up having this, right? And it's going to fail the vertical line test, and therefore it won't be a function, right? Okay, but that plus or minus is saying I'm only taking the top part of it. Okay. Yeah. All right. 5. If I don't believe in myself, what should I do? Check. Does anyone need to model check it?
Sure.
Okay. So checking is I would take this and plug it in for x. So when I take the value I got here, the square root of x minus 3, plug it in for x squared plus 3. Well, when you square root, it sets it free. Okay. And then what happens to my 3's? They cancel out, and I'm just left with x. So what does that tell me?
Right.
I'm right. I did it. Yes. Okay. Let it go, guys. Let it go.
It was too good.
It was.
Let it go.
What you just said,